to all. I hope I am audible.
Yes, sir. Good morning. Audible.
Morning. On behalf of research, I welcome you all to this webinar. The webinar is on the implementation of LTE in Indian Railways and its migration towards 5G. And today we have Mr. Parveen from Ericsson. This is about our speaker. He is a radio solution expert who is working with Ericsson, and his specialization is in LTE, NR, and he has got more than 20 years of experience in this radio network design and all. And he is associated with the mission critical networks implementation. Earlier also we have taken the support of him for delivering few sessions which received wide appreciations and all. Now Parveen is with us today and he will be delivering the session. Parveen, over to you. I'll unshare the presentation and further you can share it. Subhash?
Yeah, now Parveen is presenter, sir.
Okay.
He can share his screen.
Parveen, you may please share your presentation.
Yeah, I have already shared. Can you see my screen?
Yes, we are able to see it. You can just make it full. Okay, it's full screen now. Just try to move your slides. Can you go to the second slide? Ah, yes. Okay, it's fine. Okay, it's fine. It's fine. Okay, Parveen, you can start. Those who are having any doubts, you may please either put it in the chat box or you may please interrupt. Parveen, so over to you. You may please start.
Yeah, thank you, Dineshji. Good morning to everyone. I am myself Praveen Vadwa. I'm part of Ericsson Solution Networks team. I take care of the various private customers as well as I take care of the enterprises and public sector domain services, especially from the railway segment. My expertises are mainly on the radio solutions, and I have almost 22 years experience now where and working on the radio domain. I will be taking through to you about the LTE for the Indian Railways and its migration towards the 5G. So before we go to the detail of the session, I will like to cover a few things on the technology and the various solutions which are there for the Indian Railways for the LTE deployment, and then we will take it to the 5G for the railways, how Indian Railways can benefit from the 5G technology. If you have any questions, you can put it on the chat. Maybe Dineshji, you can interrupt me in between and then we can take up the question, or we can take it in the end as well as you like. All right, I move on. So I have kept the agenda very brief, just 2 steps, technology and the 5G. So let's go into the deep into the technology. And before that, I would like to cover up a few things about the Ericsson. Ericsson is already present in India from last 119 years. We have a various setup across India, mainly from where I come from is the EIL, which is Ericsson India Private Limited. Which takes care of all the private and the public operations, and also we have a task team which is doing the managed services of various Indian operators as well. Then we have a R&D and research operation team which is also spread across India, mainly in Bangalore and Calcutta. We have a Ericsson supply hub based out in Pune where we ship all we serve all our customers with all our telecom equipments we ship from there. Then we have a EGI, which is our global task force. So Ericsson is very much dedicatedly focused on India, where we have almost more than 10,000 employees there, and which are working for the global operations, taking care of the various customers, NOC services, and also helping them from the customer support perspective. We have almost 20,000 people which are there on our roll, and then we have more than 50,000 which are indirect employees. We are serving all the major telcos today, like Bharti, Vodafone, Geo. Then we have other enterprise vertical like Facebook, Google. We are incumbent in the BSNL and defense and MTNL. We are working very much closely with the railways as well and looking for the opportunities where we can serve Indian Railways. So we are very well associated with that as well. Coming to the Ericsson as a independent view from a technology perspective, the Gartner is one a very well known firm which is doing the independent survey on the various telecom service providers, not service providers, telecom vendors. So we have been leader in that segment of infrastructure, 5G network infrastructure and communication service provider. We have been providing the leadership in terms of ability to execute and in terms of in the complete competitiveness of the vision. So we are already there ahead of other other vendors here in the market. Coming to 5G in numbers, globally, if we see, there are 239 live networks are already live today. Out of them, 41 are on standalone networks. As per our survey, by end of November 2022, we have already covered 32% of our global population with 5G bands. If we see from the data uptake, 29 GB traffic, which we already seeing in the Korea on the 5G devices specifically. And what we expect is that that in the coming years, this number is going to grow exponentially, because 5G is again a new shift which is going to bring into the industry, especially into the communication part. And if we see the Ericsson as a own, we have almost present in 140 out of this 239 live networks. We are present in 147 live networks, where we can strongly see that more than 50% and presence in the globally. We have present in 63 countries already from the 5G perspective. Out of 41 SA live networks, 24 networks are running on Ericsson system. And we have already launched the various 78 networks with the FW, which is fixed wireless access technologies, providing high speed or high broadband services to home without any on the 5G or on the 4G bands. The devices or the products we are shipping, we have already shipped more than 9 million products which are 5G ready, and they are globally deployed. As you can see in the slide, we have various customers which are present all across the globe here. Now coming back to our agenda about the technology evolution. If we see from the chart here, from the last 40 years, we have seen the communication industry has grown. Every G, like for example, 2G to 3G to 4G has brought in a new era of services for us. Initially, when we launched the 2G, it was more focused on the voice and the SMS. Like when we introduced the 3G, it has given us as a touch base to mobile broadband, where the browsing was possible through our smartphones. Then 4G has been our app economy, where today we are seeing from last 10 years how it has actually helped us to go into the various our life segment here, and it has brought in the video, a magic of a video data over the mobile phone, where we can access, or we can come more close with the video applications here. 5G is going to be another era which we are already seeing. It has already started from last 3 years, where it is going to it is going to be kind of a digitization of our societies and industries here, and it is again going to grow into the next era, which is 6G, which we expect by end of 2023 30 to be available. So every G or the upgrade what we do, it is bringing a change into our economy, and it is helping us to look for the various applications and how we can benefit out of that. So if we see from the technology perspective, from the 5G, it is not only limited to the mobile broadband. Like we today see that various telcos which serve to us in our home segment, or to our handset which we buy from them. But we see that 5G is also going to help our various enterprises, and every vertical in the industry is going to take a benefit out of that. So like you can see in the right from the public safety, utilities, railways, whether it is manufacturing, automotive, everyone is going to see they are looking at the various use cases and how they can enhance the efficiencies and productivity in their segment. So we see that railway is also one of the prime segment where railways can benefit with this 5G and 4G technologies. Today we are going to deepen down into the how railway can benefit with various services which can be modeled around them, and it can help into the efficiencies and into the disaster recovery or into the various performances which we can build into the railway network. Before we go jump into the deep into the technology, into the use cases, let's understand the LT first, because LT is the baseline for the network today. Uh, because 5 we can also go to the 5G, but that we will see in the end of a section here. But most of the deployments in the global which we see, they are benefiting with the help of the LT network. So as a LT architecture, if we see here, there are two segments into it. One is the EUTRAN and another is the EPC. EPC is basically is called the Evolved Packet Core. This is has got a component of MME and S gateway, and then on top there are some other components like HSS and P gateway, which actually connects to the other internet gateway network elements. But mainly the EPC consists of the control plane and the user plane, which MME is the main component handling the control plane signaling messaging, which we get from the devices which are running on the EUTRAN or into the LT network. Then we have a data plane which is served by the S gateways here. These components can be in a pool fashion or into a redundant fashion as per the design of architecture the operator want to build here. So both these applications can be defined as a 1+1, or it could be in a pool kind of a services. So advantage is that in case one of the section or the area where we have this goes down, then others can take over. Similarly, in the EUTRAN, if we come down here, the EUTRAN is a baseline where we see most of the radio components sit here, and the device is also part of this. So though initially the devices, which use our mobile handsets, smartphones, they connect to the base stations. Base stations are nothing but just a active component which are radiating the various frequencies, and where these frequencies the mobile and these base stations can communicate. And the base station can basically LTE node B, which we call in the base station terms, is basically coming from GSM, while in a EUTRAN we call it this as a LTE node B. The E node B connects to the MME through for the control plane messaging, and for the data it connects to the S gateway. And these E node Bs also interconnect and talk to each other, because once the device do mobility from one area, from one cell to another cell coverage, it helps to do a handover or a seamless handover of the services from one part to the another part here. That's how the LT architecture is defined. I have just given a very much brief into that. More details we can discuss later. So LT brings in a lot of benefit compared to if we see from the earlier generation, which was 3G. Few of them are a fast time to interval, which is TTI, which actually helps to have a scheduling interval up to 1 millisecond. That means we can serve the data to the device every 1 millisecond, right? This actually helps in reducing the latency into the network, because most of the latencies are coming from the E node B and the UE. So that latencies can be reduced, because as we reduce the total time interval to 1 millisecond, so every data can be handed over in each 1 millisecond time interval. Then we see that modulation scheme, where in 3G we were limited to 64 QAM, while in the case of LT we can scale it up to 256 QAM. Then we have a fast adaptation, means that UE always checks to the quality of a signal which is getting received from the base station or E node B, and it can adapt to the various modulation schemes to serve the data or the amount of data it needs to serve here. Then also in LT, we have got various MIMO schemes which were missing earlier in 3G days. MIMO schemes helps in receiving the two signals at the same time. If the device is in a good radio condition, which we call it as a 2x2 MIMO, or it's called a MIMO technology, because user has got two receivers and the transmitter can send two separate signals at the same time. If the user is not able to form the MIMO, it can also go into the diversity mode, so that the user can be served even at the far cell edge as well, because the same signal can be duplicated from two antenna ports from the E node B end, and the receiver can receive these two signals simultaneously here. So it helps in increasing the cell edge or also the cell throughputs for the devices. Then we have various OFDM and the various waveforms which we use in LTE, which is called the OFDM, which is called orthogonal frequency division multiplexing, and then the subcarrier frequency division multiplexing. So here, this helps in the efficiencies in terms of because we can actually, the same carrier can be overlapped with the other carrier at the same time, so we do not waste the frequencies or the carriers here, and then efficiencies are much better compared to the previous generation technologies here. Then also it helps in LTE. In 3G days, we were not able to do the frequency division scheduling because the entire carrier was served at the same time. While in case of LTE, we have a frequency division scheduling, frequency aware scheduling is possible in case there are some particular set of segments or within a carrier they are having any interruption or interference. We can avoid those frequencies, and we can transmit using other frequency carrier which are available within a same set of band here. So it helps to provide a better signal and increase the user experience as well. Another thing which we see in LTE is that we have got a flexible carrier sizes, right, from 1.4 megahertz to 20 megahertz. We can choose in the step of 1.4, 3, then 5, and then multiple of 5, which is 10, 15, and up to 20. So maximum carrier size we can define up to 20 megahertz in LTE here. In LT, we have two type of methodologies. One is called the FDD, which is frequency division multiplexing, which means that we have a separate carrier for the downlink as well as for uplink. So UE has, when the E node B has to communicate to the UE, it uses a separate carrier, while when the UE has to communicate to the E node B, then it uses a separate carrier. So it's called basically the paired spectrum. While we have at the same time, when we go beyond certain frequency range of, let's say, 2 gigahertz, we start facing, we do not have a FDD, we call it as a TDD spectrum. And in these TDD spectrum, it is unpaired spectrum. Here, the same carrier is used for the downlink as well as for the uplink. So we split this carrier into the time domain, that certain part of time we only do the downlink and certain time interval we do the uplink. So it's called an unpaired spectrum. Like you can see in the picture, the same carrier is being used for the downlink and the uplink stream here. So basically UE switches in the time domain, that certain time interval it will just receive the signal from the E node B, and certain interval it will upload the data from the device to the E node B here. This slide gives about the efficiencies or the throughputs which are possible. For example, with the FDD, because we can, as I mentioned, it can go up to 20 megahertz of LTE uplink and downlink. So, and the way we can define various carriers in the LTE, right from 1.4 to 20 megahertz here. So this gives the blue one here gives the peak downlink throughput we can achieve, the peak speeds which can achieve in case of LTE in FDD band come up to 150 Mbps, while in the uplink we can go up to 46 Mbps. Similarly to this, if we have a 5 megahertz carrier with a 2 by 2 MIMO, we can achieve up to 36 Mbps, and in the uplink we can have 11 Mbps of a throughput here. These are basically, it's a peak speeds when the devices are in a good radio condition. On an average, you see that the throughputs are not every time it's 36 Mbps across the cell, because the radio conditions keeps on varying. So the average throughput in this network will be different from these numbers here. In TDD, like I mentioned, that it's an unpaired spectrum, so same spectrum is being used, so efficiency is not as we have seen in the FDD last slide. So like in 20 Mbps we could go up to 150 Mbps. Here we are not able to make 150, we can go up to 112 in the downlink, and we have a uplink of 14 Mbps. Because difference is that because we are scheduling it into the time domain now, because some part of the time is we are doing a downlink, which is most of the time we do a downlink, and some part we do the uplink. But based on the requirement from the network, we can have a various frame configuration, because like this is the 1 millisecond interval where we do the downlink, and then we have a various intervals where we can split this across the uplink or the downlink. So as per the 3GPP, there are various uplink downlink configuration which varies from 0 to 6, which can be defined and set in the network. Mainly in all the global network, we see this uplink downlink configuration number 2, which is common configuration, which is called 3:1, which means that we do if we just split it across into the number of 0 to 4, so 3 intervals are defined for the downlink and 1 interval is defined for the uplink. That's why call it as a 3:1 configuration. And in this configuration, we see the peak speeds in 10 megahertz. We can go up to 55 Mbps, which is basically effectively half of this, right? And this is with the 2 by 2 MIMO configuration. Then as we evolved from in the LTE technology beyond uh, uh, with the release 3GPP release 12 and above that, we could see that certain advancements has been defined, where we can do carrier aggregation, because every operator has got multiple such bands. So we can club those frequencies and devices can take advantage of that. So means all 3 bands are accessible to the UE at the same time. And they can also have a 256 QAM and with a 4 by 4 MIMO, which means the receiver will not have only 2 receivers, it will have a 4 receivers. So 4 streams can be generated from the eNode B towards the smartphone. Combining all these efficiencies of 3 carrier aggregation, 4 by 4 MIMO plus 256 QAM, we can achieve up to speeds of 1 Gbps in the LTE-Advanced segment. However, we have to see that device ecosystem. Every device do not support these capabilities, because there are certain chipsets which enable to do this kind of a capabilities. Not all the chipsets in the market support this. So certain high-end chipsets can do this. But yes, as a technology, we have a capability. This type of showcasing can be, or this kind of a deployments can be done into the network in a commercial network as well. And most of the advanced markets are already there with these kind of a capabilities as well. Then quality of service is a prime requirement, because when we go into the commercial network, we have various set of services which are defined, let's say between the voice and the data. Voice needs to be always prioritized over the data, and with the guaranteed bit rate is required on top of that. So we define this QoS into 2 segments, which one it is called the guaranteed bit rate GBR, and then another is called the non-GBR services. Within a non-GBR services as well, you might have a different set of services, maybe a video on demand, maybe a buffered video or video streaming, or it could be anything else for the data browsing, FTP. So all these services can also be segmented and differentiated in the non-GBR network as well. So we need to define a certain quality of services for each of them, so that not only one service do not take over the entire resources of a network, and it actually. Hello.
Pavin, we can hear you. May I please continue?
Yeah. So it is not like that one service should take over the entire set of resources and other services are starved off because of the one service. So we need to split this into a model in a way that quality of service is implemented and all the services are available, and then there is a set of guaranteed bit rates are associated with certain services, like for example voice, and within a non-GBR we can define the prioritization within that segment as well. And why this is more important, like if we look at from the railways perspective, I will because in railways or in the public safety domain, there is a term we call it as a mission critical services. Because example we take is that, let's say any accidental area, when we have a lot of people who are together and they are trying to latch onto the network, while we need to prioritize certain subscribers, and those subscribers need to be differentiated. How you will identify that these are certain subscriber which needs to be prioritized? So there is a certain allocation which is called, we call it as a certain services which is mainly mission critical, which we call it a MCX, or MCX could be in the terms of voice, it could be in terms of video, or it could be in terms of data. So 3GPP has actually defined a special service for the mission critical such operations, which you call it as MCPTT. And we can have a certain, there are other than certain other QCIs defined as well. So here this picture gives about this, that quality of services not only exist at one part of the network, it is basically end-to-end deployment. Let's say right from the core network to the intermediate transport node, then to the node B, we need to define the various quality of service, and based on the implementation, the type of services network is using, whether it is a voice, whether it is a data. So those services need to be activated, and then parameters need to be set into the network here. So railways will really benefit from those differentiated services, like we mentioned about the mission critical, because in case of any emergency, those services need to be prioritized here. And also LT has got a wide carrier spectrum. They are and enrich of a throughputs and lower latency. So railways can really benefit out of those services in comparison to what today the railways network we see, like for example GSMR, which is mainly around the TCAS, and then only on the voice service, while some other services like a CCTV, or which is basically from the surveillance, and other PAS are working on the Wi-Fi bands here, while LT is a wider band, and it's a unified network which can serve all these services at the same time. So we can address to the requirement of high signaling, which is TCAS, which can have a monitoring across the platform, whether it is a mission critical voice services at the between the loco to the station, or between the loco to loco. It could be a CCTV surveillance on the station, or on-board services, PIS, train telemetry. All these services can be scale in, scale out onto the single LT network. That's a flexibility, and then the network need to be defined with a certain quality of service for to serve each of these services at the same time. That's where the LT it becomes the prime importance, or gives the differentiation from the previous generation networks here. So apart from this, like we see not only the TCAS or the voice, there are certain other services which we can also activate. For example, the mission critical in case of a disaster on the ground. So those field operations which are there on the ground can be prioritized, and it could be given a video and voice priority over the other certain people which are already there on the ground, because when the network gets choked, so people are not able to communicate. So these people, field force services, which will be supporting and they're working there, will be having a priority over the certain number of users there. Then you can have a train control platform surveillance. It would be wayside monitoring, train health monitoring. So various IoT application basically can also be activated on the same LT network as well. Most importantly, LT need to be reliable, and it is there. It is already reliable network. So, but railway, from a railway point of view, three segments. These are the critical one. One is the lower latency, because uh, every application need to be like, for example, signaling has to go at the highest speed, and the voice need to be prioritized over other services. So latency is a must for the network. Then the coverage, because the entire railway track need to be covered. In case any in between there is a black hole, the coverage is not available, it is going to have impact on the railway operations. Then the capacity, because once you have so many video surveillance application or the video on demand, like for example CCTV, or maybe it's a kind of a passenger services, passenger Wi-Fi services, could be like, for example, if the railway want to deploy those kind of applications, so those will require a high capacity. So all these can be served at the same time and with the reliability of 99.999%. The only thing is we need to ensure that the proper planning, the set of right set of frequencies and right set of sites are deployed into the network to meet such requirements here. We will go into the now railway design and site solutions, how we as Ericsson envisage that that railway can benefit from our global deployments. So if we see that, like we have previously seen in some of the slides, how the LT network can be. One is a entire LT architecture, which could be EU TRAN as well as the EPC, where we have a MME, and then we have a S gateway, P gateway, and then we have a E node B set up there in the network, and which is enabled with the various quality of service application, right? So it could be voice signaling or the video, and then certain core elements, applications which are sitting across outside this core network, which could be MCPTT, like for example the dispatcher or MCPT client. Then it could be some other applications which are required to be delivered on ground. So on ground, or on the cab system, on the loco, we will have a LT cab modem which is installed on top of the loco, which will have external antenna can communicate to the respective node Bs at the same time. And then through this modem we can attach to the ruggedized MCPTT system, which is basically a mission critical push to talk voice services there. Then you can have a on ground people on the loco can have a handheld devices. There could be a certain surveillance applications which can also go using the same modem, or it could be it can directly talk to the network directly as well. Uh, on a nutshell, these kind of services can be used. This is what we see, that the initial start of a railways can Indian Railways can benefit, because the type of spectrum we have, it's only 5 megahertz. So we are limited with the amount of a high speed data. So certain critical application, for example the TCAS, the voice, these applications can easily be used from the as a baseline, and then we can scale these services later when we add more bands into the railway operations. Like I mentioned, that coverage is a prime factor in LT. So across the route, the communication has to be there, the signal has to meet, and also redundancy need to be maintained, because we cannot have a single E node be switched off into the network, because if any site goes down, the TCAS is basically relying on the every second communication, right? So TCAS signaling on the loco need to talk to the central server. If they are not able to communicate, the train will immediately stop. So we need to ensure that the coverage and the track is available even if we have a failure of one of the site. So the planning part aspect has to be very important. Role plays a very important role here. So how we can actually cover the entire track, we will see in the subsequent slides. Uh, so there could be like we have seen in the last picture, we have normally the tracks in the left hand side. We do not need to, in a normal commercial world, we need to cover the 360-degree coverage. So when we deploy any site, you must have seen that 3 antennas are deployed at the site, while in the railway operation we do not need 3 sectors, because we have to only cover the x axis and the minus x axis, or the left and right section of area, right? So we can only serve this site with the only two radios here, or the two antennas here. So what all other components which this site will have once we LT network get deployed? Because when you deploy any site, you need to have a tower, like we can see here. It's a because antenna need to be placed, and so that it can cover the larger distance up to 5 to 7 kilometers. So you need to have a physical tower on the site across the track. Then we will have other components like transport, because the how you will connect this system E node B to the core, so fiber or some push transmission media needs to be there. Then you have a E node B, there are two sections. One is called the baseband, which is called the digital unit, which is basically the main brain of a system, which actually interfaces with the E node B with the devices, and then it connects to the core elements. Then baseband has connectivity to the radios, which serve and in which in turn connects to the antennas here, and then antenna serves to the connects to the respective devices on the ground here. All these components can be housed inside the enclosure, because when you are there in the field, either you have a kind of a enclosure system to serve all the active components, or it could be a shelter. So based on these two options are available. However, Ericsson has got a unique design that we can actually mount everything on top of a towers because of a security reason. In case we see that we do not want to put all these components on the ground, we can also have a solutions which can actually put in all these components on top of a tower, like for example battery system, router, baseband, radios, everything on top of a tower. So there is nothing, it's a zero footprint, and it's a full secured kind of a solution, right? So this was about the how the site components will look like for two sectors. Similarly, we can scale this into three sector if there is a kind of a area which is having 3 to 4 routes at the same time. So we can put more sectors at the same site to cover up the 360-degree coverage as well. On the high level, this is how the three sector site will look like. We will have a baseband unit and which interact with the IP MPLS or routing system, and then in turn it connects to the radios and the antennas here, like we have seen in the last slide. Then we have an enclosure. This is very much simplified diagram to understand how the telecom on the field will look like. Uh, this gives the list of the components I've already covered in the last slide, that what all elements needs to be there on the site, like radios, baseband, router, power system, battery bank. And if it is a two-sector full outdoor, there could be an intermediate site. I will show you how we can design this network in a way that you can have one site which is having all these components, but the other site, like intermediate site number 2 and 3, do not have and the baseband and the routing systems, because we can have, because on the track fiber is already available, we can connect these remote sites only having a radio system using the railways fiber which is already laid across the track, and then this radios can connect to the remote baseband system. So advantage is that we do not have an entire set of a components at every site. It saves it saves the energy, as well as has the TCO advantage as well, because we do not have all the active components at every site here. Apart from this, the solution can be need to be defined in a redundant mode. As I said, that in across the track we cannot have even a single site failure, because if we have a single site not running and no coverage there on the path, there is a case that trains will stop because TCAS signaling will not be available, right? So how do we address that? So what we do is that we plan the coverage in a way that this site, which is having a antenna direction, it is facing towards the right side, need to deliver the coverage till the leg of a other tower. So let's say station 2 provides a coverage till the leg of a station 3, right? And then vice versa, the station 3 provides a coverage to the leg of a station 2. The advantage of doing this is that in case there is any failure of any site. For example, like you can see in the next picture here. Yeah, so like you can see if there is a, for example, there is a complete failure of one station, one of the active component, either it a baseband or the router or anything goes down, at least the green one, the intermediate site can still provide coverage across the path, and then the train which flows across the path here has a connectivity there established. The connectivity is still maintained across the track seamlessly. So that's the advantage. So this planning need to be done in advance, that the way that we have shown just now, that the coverage of one site should be go at least to the leg of a other tower. That's a must here. Yeah. Then we move on towards the 5G for the railways. Uh, Beyond the 4G, like we have mentioned that it brings in the new innovation, and also the digitization is happening in the industry, where every vertical in the industry is going to benefit. So idea of behind the 5G was to not only serve the EMBB devices, which is the mobile broadband services, was also to connect to the various FWA, which is fixed wireless access. So it's kind of a replacement of our existing cable network, whether it is a copper or it is optical fiber. So it can provide a similar kind of experience over the air using the mobile broadband services, or using the 5G services to the home. Apart from this, industry verticals gets if also can generate their own kind of a services with the massive IoT, which is machine to machine communication, or critical IoT, where we can have a thousands or lakhs of sensors on the network, which can generate their own health status to the central point here. So we see that these four pillars, which was important, and then it delivers the speed, coverage, and reliability. On top of that, this 5G platform here. So we have seen earlier that these services are going to be another revenue streams. How the 5G is going to benefit from compared to 4G? We will have a higher frequencies. In 4G, we were having a frequency till 2.6 gigahertz, while in the 5G, we see the frequency range right up to the 28 or 38 gigahertz here. I will show you in the next slide, but just to get a glimpse of this, that we will have a higher frequencies and the very short waves here, which means that in the higher range we can have a higher carrier sizes, which means a wider carrier. Like in LT, we were having only 20 megahertz of a carrier, while in 5G we can have go up to even 100 megahertz or 800 megahertz of a carrier sizes, which means that we can achieve higher speeds compared to LT network. Then we have advanced antenna technologies, which we call it as a active antenna system, or we call it as a massive MIMO, where radios are even further are made intelligent, that it can create a beam signal. In a normal standard classical LT days, or in the LT bands, we were providing a coverage to the all the subscribers at the same time. Here we what we do is that we use the intelligent beam forming, that the specific beams are generated to the specific user. So as the user moves across the cell, these beams also take their change their shape, and only produce the signal towards the respective user, so that two users do not get interfere at the same time. So it reduces the interference, at the same time it provides the higher gain, and that means the higher speeds can be achieved to the subscriber. Then the leverage of existing install base, Ericsson has already deployed 9 million of a devices, or the nodes which are already 5G ready. So those bands can also benefit with the 5G application. Then architecture is a new architecture, SA, which we mentioned was standalone architecture. I will detail out more detail in the next slide what actually it means. So if we understand 5G more in detail, so we can go up to low band, which we were already using in LT, like 700 megahertz, which is band which is being currently used by railways. But in the commercial world, we have in LT bands which was going up to 2.6 gigahertz. This is where LT ends. But when we talk about 5G, the 5G has another scale of bands like 3.5 to 8 gigahertz, and which is called the mid band 2. Then we have higher bands, which is high band, which is 24 gigahertz to 40 gigahertz. So as we go across these high frequencies, there is the coverage challenge, because there is a lot of attenuation on the propagation losses are there in the high bands. So this is limited with the coverage. But from the capacity perspective, it gets an advantage, because as we go into the high bands, we have a higher carrier sizes, so capacities can scale in, and and the technology can be evolved in a way that we can reduce the latency as well, because as we go into the higher bands, we keep on reducing the TTI, which we mentioned in the first three slides, that LT has a TTI of 1 millisecond, while 5G can reduces the TTI even up to the sub-millisecond. Hence, the latency can even be improved further in the network. So this is kind of a high level understanding how 5G benefit from a technology perspective. And then from an architecture perspective, we know that LTE was a standard design where UE can attach to LTE, then EPC. So in a 5G world, the UE with the 5G capability can connect to the NR. Here we call it as a LTE. Here we call it as a NR, which is a new radio. And then we have a 5G core, which is kind of a replacement of EPC, where we have seen that evolved packet core. Now it gets into the 5G. It is renamed as a 5G core here. There is also a mid-bay that operators are using there in the global. The reason being is that all the operators, like you have seen in the initial my slide here, we have more than 260 live networks there globally, but out of that, only 60 networks are on SA. SA means it's having they are ready with the 5G core, and they are ready with the 5G base station. While all the networks are not 5G having a 5G core day one, because it takes time to scale to that level. So intermediate step for the 5G has been, which is called option 3x, which is called the ENDC. So where the networks can use the UE users can, which is having a 5G enabled, can still access the NR bands, but with the help of existing EPC. So there is a minor upgrade which needs to be done on the existing 4G EPC to make it as a 5G EPC ready, and then still they can connect to the 5G bands here. But when we talk about the LT in NR in the railway segment, we will not focus about the NSA, because SA has its own true benefit. I will show you how SA has a true benefit, because this design of option 3x in the NDC is only meant for the commercial world, but not for it is not having the enhanced feature or the functionalities which the 5G is expected to deliver. So with the SA, the SA with a true 5G comes with the various advantages here compared to NSA. We can create an end-to-end network slicing, because various services can be differentiated. Then we have advantages in terms of a signaling here, because latency is much better. The way the messages exchange happened on between the network, it is much smaller, so latency gets improved. Then we have advantages in terms of coverage, devices, and then when the devices move to the 5G band, it offloads the traffic of 4G. So the 5G experience, 5G devices itself gets benefited, and 4G network also gets relaxed, and the 4G experience also increases. So there are certain time critical communications, like we have seen the low latency, which it can advantages that we can go into the critical IoT, number of sensors, and machine to machine communication. With their certain technology changes, we can actually address those segments as well in the 5G, which is and then, like we mentioned about the how railways can benefit on the 5G. If we talk about 5G upgrade, so in a normal in a commercial world, and with the slicing on top of that with the 5G network, so network resources can be cut across in a way that certain part of the resources are allocated for the broadband users, commercial users, and certain services can be assigned to the railways. And within railways, certain applications can be drawn, like some high priority to low priority. High priority services can be given to the driver, like for example MCPTT for MC video, or it could be security, surveillance, or onboard services which is there, or to the passenger Wi-Fi services. So you can differentiate this within a slice which is given for railways. So that kind of a differentiation is only possible when you have a true 5G deployment into the network. And if we just compare from the LTE to NR, so there are certain terminologies changes here, like we have seen in the previous slide. LTE has been, or in a 4G it is LTE, then MMES gateway, which we discussed just few minutes back here. While in NR, it gets replaced with the new terminologies, which we call it as a UDM, UPF, SMF, PCF. So they're a kind of a replacement of individual section which was served for the 4G, because it's a new core, new certain signaling messaging comes into picture, which are more faster, more advanced, and it helps to create a flexible network like network slicing. So those applications come when you have this 5G core deployment into the network. So how railways can aligned with the commercial world? So there is a body which we call it as a FRMCS, which is Future Railway Mobile Communication System. Those are creating a standards globally for the railway deployment, which can benefit with the 5G services. As we speak, this FRMCS conference is going on, which is happening on 7th and 8th of 2023 here, and they are looking at the the current specification standards status, and how they can evolve it towards the future FRMCS standards as well. I will go into the most detail of FRMCS, what actually FRMCS sees, look at that. FRMCS actually look at this one from the 3GPP release 18 perspective to address the various mission critical services, then aligning it across the various functions, right? And then like we know that European train system is one of the complex in the world, because the one train goes from one country to another country. There is certain change in the regulation, so they need to harmonize their operation. So there is a certain single body which addresses this, which is a European train control system. Automatic train operation services, critical video services, train management, wayside network slicing, all these operations or the functionalities they look at, and how we can be given to the given to the bring brought this into the railway system here. As Ericsson, we are already leader into this segment, and we are working very closely with these groups, and we are part of a standardization body, and also we have showcased certain use cases on the ground. As the standards are evolving, we are also doing trials on the field and trying to showcase the benefits of this technology. I will show you some of the slides here in then how we are where we are in terms of use cases. Coming to FRMCS, has mainly three pillars. If we see, one is the FRMCS provides the feature required for critical train communication replacing GSMR. That's a pillar number one, and which can address to the 3GPP MCX features. Then the 5G architecture framework, which can handle end-to-end communication on board system. Then we have IDEA FRMCS is defining certain new bands here, which is this is basically coming from the European standard, but does not limit to the only to this band here. We can also scale to the certain other bands as well. So these are the specifically bands which are designed from the European standard perspective, and then they provides a better flexibility that any of the QS can be used for any service, because 3GPP has certain set of services tagged to the certain QS, because but they are actually coming up with the flexibility of the better flexibility here. Then if we see the railways, because railway has got a limited band in the global, like we can see here, they have got only 5 megahertz or 6 megahertz of a band here, while or 10 megahertz is also there in 18 and 19 to 1910. This is a specific band which is being standardized by the FRMCS, but all these services what we talk about not possible within a same 10 megahertz. So another model which is being looked after in 5G is that to align with the telcos, and then uh, do kind of a RAN sharing in the network. This is very interesting, where both these parties can actually help each other. For example, the railway has got a various civil infrastructure where it can do a passive sharing. It can allow the operators to come on board and then uh, set up their sites across the track, and then this band can be used by the railways because this mobile network operator has got various bands in mid band which is of a higher carrier sizes, and they can actually railway can actually share this kind of a bands with them and then set up their own uh, or digitalize their own setup with the various services, right from the voice to video, and providing a various mission critical set of features on top of that on the same network. So it's kind of a win-win situation for both of them. It can be, this is how FRMCS is trying to generate a kind of a handshake between the two lobbies here. And we have seen such kind of trials. Last year we were present in Innotrans 2022 to where we showcase few of the use cases, because FRMCS we see that we more aligned to the 5G core. So there is a certain in the railways we see that the trains windows or the glasses which we basically use are not aligned because they create a lot of penetration to the external signal. So we brought in the concept of special window glass which are actually placed onto the train, and within a train we got a devices which were connected to the 5G core and 5G setup, and then where we could showcase the speeds up to 1.3 Gbps onto the within the loco system or to the passenger system sitting inside the train. That's how this trials was performed there. This was a demo which we showcased. Apart from this, in the 5G and with the mission critical requirement from railways, from the voice to video surveillance there for the cab services with the cab radio, MCX clients, all these setup was made there on the within the loco, and then that was demonstrated by connecting it towards the various core setup. And here we demonstrated the private call, group call, and the video system. All these services which is aligned with the FRMCS standards has been demonstrated. One of the major successful commercial deployment has been done by Ericsson with the Swiss Railways, and we are incumbent into the Swisscom network, and where the concept was to where the objective is to provide the gigabit of a speed on the train trial network. So in the Switzerland we have already showcased a few areas where we could achieve on train 1.2 Gbps of speed. This was done in coordination, like I mentioned, between the Swisscom, which is the operator there, and they are owner of frequencies of up to the 5G frequencies in midband, and they have aligned with the Swiss Railways to deliver those services. So here you can see that the on track within a 10 meter the site was installed, and then inter-site distance was kept small, like right from 700 meter to 1.2 kilometer, and the idea was to deliver the 1 Gbps of speeds on train. And along with that, on top of that, the loco services, the like mission critical services was also made available to the railways as well. This was all about global. In India, we as Ericsson, we have tested the TCAS services as well over the LT network with our partner HBL. They have their lab set up in Hyderabad, where we set up Ericsson base stations, and those were connected via this the over the air or over the cables to the LT cab modem, and then toward the loco TCAS system here. So where we could showcase the demonstrate the capability of TCAS running over the LT network with the switch with the various use cases like handover from one base station to another base station, as the user moves from one side to another side, how the handover is going to happen. So entire set of signaling exchange was done between the loco and the station TCAS. This has been widely shown already to the railway body as well. Globally, if we see, we are already in a very advanced stage. As I mentioned, Swisscom is one example which we have collaborated and showcased this capability. India, we are already there. We have a lab setup. We have already demonstrated there. Then we are also working with other global operate railways bodies, like for example, Japan, Russia. Then we are present in Deutsche Bank, where we are closely working with 1900 megahertz of FRMCS trial, which is the band which is going to be labeled for a European train system. Then also we are working with the Latin America as well as America on the railways various applications here. So in the end, this is my last slide where as Ericsson, we are having a market leadership, not only into the commercial 5G, but also we have a ready-made solutions for the railways applications. And we can serve from the 4G to the latest standards of the 5G as well. We have end-to-end references, and we are working very closely with the standardized bodies as well to demonstrate or bring up the best in the class solutions for the global system here. Thank you. That's all from my side. Any questions we can take up now?
Thanks, Pavin. If anyone is having any questions, you may please ask.
Sir, is it MCX server is compulsory in railways working, or is it optional?
Sir, again, MCX provides a mission critical services here, so it helps you to have in a normal server will not be able to allow you to make as a group call or to kind of make a point to point. It will only be limited to a kind of a point to point call. So mission critical server will help you to create a segregation. So mission critical server will be required, in my view, from a public safety perspective.
Pavin, one thing, whether Ericsson has got the MCX application.
Yes, we have some tie-up with the third party for this MCX solutions.
Okay.
So, good afternoon, Praveen. I'm Assistant Professor Telecom here. Thank you very much for giving a lot of insights into the subject. Can you hear me?
Yeah.
I just wanted to ask you, okay, your manufacturing facilities. Do you have any manufacturing facility in India?
Yes, we do manufacture in Pune. We have a manufacturing setup there, and we are supplying to all the operators here and all the enterprises solutions which we are offering. So those are getting delivered from the Pune factory.
Okay, what do you manufacture here? E-Node B, the EPC, and everything, or?
No, EPC is mainly from the because most of the things in EPC are mainly cloud based. So we have
Okay.
it, and that hardware is coming from the top vendors like HP, Dell, and because mainly
Okay.
this is on-prem or to the cloud server, but we have our own software there. And
Okay.
in Pune mainly it's a setup is only for the E-Node B and G-Node B there.
Okay.
So we
So that
manufacture radios, basebands, antenna systems, all things get manufactured there.
so mostly pertaining to NR and E-Node base.
Yes.
Okay, so then now you spoke at length about FRMCS, but this FRMCS is a part of 3GPP standards. That means, or is it a standalone for railways?
So it is a standalone for railways because FRMCS takes standards from different segments. I can show you one slide which will help you to understand in the FRMCS perspective. Yeah. So like you can see how the standardization is done in FRMCS. FRMCS has takes the inputs from the UIC, which creates a user requirement specification. Then we have ETSI and 3GPP. So
Okay,
FRMCS is a body which comes under the 3GPP here, Future Railways Mobile Communication here. So 3GPP also defines the FRMCS standards here. And then also it works with the ETSI as well, because European telecom standards need to be followed in Europe. So they also follow this.
Then there must be some exclusive vendors who are supporting FRMCS. It may not be commercial vendors who are supporting these commercial operators like Geo and Airtel. They may not be able to fulfill our requirements, right?
Yes, so they will not be able to fulfill your requirement because FRMCS will require a certain set of applications separately out of the commercial world. Like I mentioned about the quality of service, right? And
Yeah,
then like push to talk, MCX, and uh, certain like maybe EMBMS because it's a mobile broadband. It's called the broadcast services are there. So standard operators like Geo and Airtel might not be able to serve. And also, you must have seen that in the disaster case, for example, the way it has happened in a Odisha. So what we are hearing is that has been a lot of choking of a network, right? So if there could have been a case that you have your own network, or your own users might be able to talk to and communicate to each other. While when you have if your services mixed with the commercial world, you do not get any priority over there.
yeah, that is true. That is true. So that means you recommend to us to have our own dedicated communication network supporting FRMCS.
Correct.
So then
So,
one
so
more thing I
FRM,
wanted to ask you.
yeah, just to add here, FRMCS is a standard which is currently the FRMCS is not working on the 4G part here. The current set of FRMCS standards is going to come with the 5G. The first wave
Okay,
is only about the 5G. But since we are
okay,
away from the 5G deployment in Indian Railways, what we see that you need to first take a step in LTE first. Let's plan for the LTE. Let's do a deployment in the 4G world. Let's set up the infrastructure, and then we can scale it when the FRMCS standards are proven and they are ready, then we can upgrade our system there.
so then you have to become NSA and then become SA.
No, we do not see that you'd have to become a NSA here. You can straightway move from 4G to 5G.
Okay,
So
okay.
NSA is a step for the commercial world, right?
Mhm.
Because they have the additional frequencies, and they need to because their commercial network are having a LTE, so all the users are not having 5G today. While
Correct.
when you upgrade your network, you can actually scale right from 4G to 5G very easily. So you can have a backward compatibility as well as a forward compatibility.
Okay, okay, good. Well, one more last question before I give it to you. See, you have covered this redundant elevated coverage model, continuous coverage.
Right.
So station one, station two, you said the coverage will be extended from the station two leg to station three leg, so that if
Correct.
one setup fails, other fails. Then what is the spacing you have assumed between two stations?
Okay, so it depends what is the throughput we are trying to achieve. If the throughputs are quite high, then we might have to have a quite close number of sites. But if we look at the standard application of railways today, like only TCAS and the voice, and the again depending on the number of trains we are envisaged to run at the same time, we see that 5 to 6 kilometer is a good enough distance where we can serve. So with a band of 700 megahertz, right? The
Yeah,
current band which railway has, and you have a 5 megahertz of carrier, assuming
correct.
that you only need TCAS and the voice application to be served, 5 to 6 kilometer is very easily we can support.
But by all the station spacing between two stations in railways is more than 5 to 6 kilometers. So we require some intermediate trackside
Yes,
equipment.
yes, that will be required because
So we
once
may
you
have,
if your let's say distance is 7 kilometer and you are not able to meet the coverage in between 7 kilometer, you might have to put one more station site here. And also it is
so
not a very it's all depend upon the track route, like foliage losses, how much dense it is, whether it is going through a open area, whether it is going through a curve area, maybe tunnels, something. So all those factors needs to play a big role here.
okay. But this installation of trackside equipment between two stations, how complicated it is? It is easy. That is, it can be outsourced, or it can be, that means without manning you can provide.
Yes, that's what I was trying to showcase here, that we have a solutions around where you just need a tower, right? So
Yeah.
and then you can have a kind of a boundary wall so that nobody can interfere, and from a security point of view, it is safe. We have a solutions which we can just mount everything on top of a tower,
Okay.
because in where you have a safety, because safety is prime here. You might have some kind of a threats and theft and all those issues here. So to prevent
Exactly.
all these accidental issues, what we can do is we can put everything on top of a tower, like you can see in the picture here. We have
Yes.
got a radios, basebands, we have got a battery system, everything sitting at the 20 meter 25 meter height, right? So which means
Okay.
that there is a safety around the tower. Because if you put something on the below the tower, yes, if you want to do it, you have enclosure or you have some kind of a shelter. We have a solutions on that, but we understand India market and we have a solutions which can actually provide you the everything on the top of a tower with a very compact design, like you can see here.
Yeah, correct. So what will be the tower height like?
The tower height, depends. It is could be 25-meter to 30-meter.
Yeah,
It is all a planning, right? So some areas we might need even a lower size of a tower, because
correct.
like you mentioned, if the intersite distance is 7 kilometer, but you need coverage in between, so you might not need a 40-meter height tower. You might work with a 25-meter tower as well, right?
Yes, yes. Okay, thank you. I think a lot of people are waiting for in the queue.
Point one thing, it's regarding the MCX. Now, a lot of companies are claiming that they have MCX solutions with them, and most of them they are making OTT. It's all OTT applications. So, how we will be able to ensure that whatever the MCS solutions which they are bringing, that they will provide the necessary QoS requirements?
So as I mentioned in the discussion, that there are certain MCX applications which can be tagged to the because all these applications sit behind the 5G core, right? So this 5G core can interact with this redefine the QoS which we want. So we can actually have a association of this service from here to here, okay, and then when we feed this service into the network, we assign a separate QoS. Maybe it's a, even if it is a MCX with this, which is not having a IMS service, or it is having a OTT service, so we can tag it into a separate QoS.
Okay.
We understand that most of the MCX are not having a true IMS kind of application. They are working on OTT. So, but it is feasible. Technically, we can actually define this into a messaging, which is actually a kind of a high priority application here, because OTT voice need to be prioritized over the standard data application.
That means you can have an MCX which will be acting as an OTT, and in our core you will be assigning the QoS.
Correct. Correct.
Okay. Okay. Thanks.
But this I'm talking about our system, our 5G LT system core, which we have solutions available. You need to check from the core. If you have some certain other core, I cannot comment whether they can really do it or not.
Fine. Okay. And another thing is, in your baseband, the baseband you have shown in one of the slide, whether this baseband can be connected to multiple IP/MPLS routers.
Yes, it is possible to connect to various MPLS network for a protection. Like for example, we can support BGP, or we can have some other our protection mechanisms, dynamic protection mechanism into the network. Let's say if one path of a transport fails, the other can take over.
Okay. And regarding this radio unit and the antennas also, these they will be having multiple ports. And in one of your diagram, you have shown that there can be a cross connect. Is
Correct.
that possible?
Yes, it is. This is very well possible. This is one of the unique thing which we do, and we always define it in our all solution. The reason being is that if there is a failure of one cable, for example, do not have this one. Yeah, this one. So like if there is a failure of one radio system, at least your second radio is available. For example, this goes down, so
Okay.
this green path is not available, right? But at least this path is still available, because one port of this is still connected to the second radio.
Whether these other vendors like Nokia and all, are they following this? Whether their equipments, do you have any idea on this? Whether their equipments are also suitable?
I have no idea about them, so cannot comment on that.
Okay, fine. Okay, thanks. In case if anyone is having any doubts, you may please ask.
Sir, what about this dispatch server, sir? Is it required for railway perspective?
Sorry, I understand. I'm not an expert from the dispatch, but I understand that dispatch will be required because how you will have a you know user view onto the loco.
In
When you
addition to the MCX server,
correct.
both should be there as the railway perspective.
Sir, I'm not expert of MC of that part, so I may not be able to give you a right answer. Sorry about that.
Okay, thank you.
Dr. Parveen.
Good afternoon.
Yeah, this MCX voice communication, is it like broadcast only?
So you can have a group call, right? You can have a point-to-point call. Both are possible.
Okay, thank you. This MCX server is integrated with some SIP core, or do we require a separate SIP server?
But when you say SIP core means
SIP server, I mean, for achieving this Vivo LTE. So it will be like Vivo LTE call only, na? Whatever the call on MCX, that is
correct.
like Vivo LTE call
Correct.
only.
So it will not be a VoLTE call. It will be a data call. But like somebody raised a question about OTT voice, so it will be OTT voice.
Okay.
So if you have a IMS, then you have a voice over LTE, which is
Okay.
basically a native voice. But here we are not in MCX not having a native voice. It will be a kind of a voice over voice. It's a data basically where we write the voice on that.
So technically, we cannot call it a VoLTE call, right?
No, we cannot call it as a VoLTE call.
Okay. Only with IMS that VoLTE
Yes,
functionality can
yes.
be
Only with
achieved.
IMS VoLTE can be achieved
Right. Thank you.
because the coding mechanism of VoLTE is different from what with OTT does.
So the QoS of VoLTE is better.
Yeah, of course, QoS of VoLTE is better because these are linked with the 3GPP defined QoS there. But like I mentioned, OTT voice can also be segregated. So we can define the MCX service which is coming here. Instead of giving it into the VoLTE service per se, like there are a certain set of QCI assigned to the VoLTE, which is QCI 1, QCI 5. So in the MCPTT world, we can define these MCX services to the mission critical QCIs, right?
Okay.
But the only thing is that integration between the five core to the system has to be done. I cannot comment on the core, like our system are unable to do that, but I cannot comment on the other core how they can do it because this integration of QCI with the external world need to be done by the core system.
So if we implement it as a OTT, then that configuration may not be possible in the core, right?
If the core is not able to segregate then this service, then it may not be possible for you. If the core is intelligent enough to segregate this service and put it into the MCPTT service, MCPTT QoS, then it is doable because the QoS flow happens from the top to down. Like I can go back to my previous slide and explain you again. Yeah. So you can see that this whole policy and the enforcement of QCI comes from the packet core, the packet switch network. So where let's say we are defining QCI 8 here, maybe signaling is defined by QCI 5, then MCPTT is defined by QCI 65. Now here is a catch here. Somebody has to understand, map this from the core. Let's say you have OTT server, right? So OTT goes into the core and the core maps it into this QCI. If the core is not intelligent enough to map it into the QCI 65, what will happen is it will put it into the standard QCI, which is QCI 8, where everybody is sitting in the same QCI. And now if you have a certain prioritization required, then it will not be possible because end user is again all the services are mapped to the same QCI. So it is not a healthy situation to be. I hope I could answer explain you this point.
Yeah. Thank you.
Any more questions?
Sir, I have one more question to ask. This now you are saying FRMCS is based upon total 5G technology, but whatever the bandwidth and band 700 megahertz and 5 megahertz bandwidth we received, definitely not suitable for 5G. So we need to get a separate band and separate bandwidth also.
Sir, it depends on the application what you are trying to put in. So, 5G brings in the entire new dimension to the services. You can have a lot of things can be done. It's all depend on the size of a carrier and the capacity you want to draw from that. So if
But
your
can I use the
application is
same spectrum? Can I use the same spectrum and same bandwidth? That is what my question.
yeah, so 5 megahertz, we believe it's a quite small carrier. It will able to serve you the limited capacity. So let's say you want to have only voice and the TCAS signaling over there. But if you want to run any video application, because these applications are mainly driven from the uplink perspective, let's understand this point very clear. 5 megahertz uplink will be, as I mentioned in the earlier slide as well, what is the capacity you draw from 5 megahertz? So the capacity of 5 megahertz is hardly 11 Mbps in the peak condition. But if we look at the from an average cell condition, the cell edge user, which will because every user need a same throughput, right? Whether
Yeah.
it is sitting in the close to the base station or it's sitting in the cell edge, he need, let's say, 2 Mbps, 3 Mbps uplink. If every user has to do 3 Mbps uplink and you have only 5 Mbps carrier, 5 megahertz of a carrier, this may not be possible, right? So your quality of video surveillance will drastically reduce. Maybe videos will reduce the codec to the lower one, and then the person who is actually collecting the data or want to see may not be able to accurately see the picture clearly, right? So 5 megahertz from in terms of video surveillance, we do not see a good band or a good carrier size. So you need to have either bigger carrier sizes. Maybe that's why FRMCS is trying to collaborate with with the telcos spectrum. Like I've shown 1 Gbps of a speed in Swisscom. So they have done a collaboration with Swiss Railways, and then it's a kind of a mutual sharing between the two parties. So the railways is getting benefited with the higher band with the onboard services of videos, surveillance, and other downlink and uplink services there. And then on top of that, they are able to run their own MCPTT services as well. So it's a kind of a collaboration you have to do between the telcos, or you need to have your own network which is having a carrier size. Let's say you take any spectrum in mid band or any other carrier size which is beyond 20 megahertz of a carrier, then it is good enough. Then you can have run so many services on the video, because uplink, all this data surveillance will require a uplink, so you need a higher carrier.
Yeah. So, but what about the European systems? So, European countries and these countries will be having a separate bandwidth and band allocated for them dedicatedly, or they also follow like India conditions only?
So currently, if my knowledge says that FRMCS is mainly focused on 1900 megahertz, because this is the spectrum that is only 10 megahertz carrier, but they are trying to tie up with the telcos to increase as well. At present, they are having a 10 megahertz of a carrier.
Okay.
Pavin, there is one question in the chat box. It was raised by one Mr. Salman. Can you see the chat box?
Can you read this, please? I don't know where it is.
Is it possible? I will read out the question. Is it possible to increase the range between the LTE towers? You mentioned as 5 to 7 kilometers. Is it possible to go up to 20 kilometer considering your track is straight? You have already covered this.
Yeah, so it is possible. As you have a higher size of a tower, and then the line of sight is clear, definitely LT can also scale up to 20 kilometer. That's not a problem. But yes, we see that the amount of data uplink will be very, very small, because 20 kilometer is a huge distance there. technically you can make it 20 make it as a 20 kilometer possible, but I believe that along with the CPE, the train onboard system, because today the the this one, the what do you call it, as a the cab modem is having a omni antenna, right? And they do not have a much of a gain here, so maybe we have to also increase the gain of this antenna to reach up to 20 kilometer. In a commercial world, we have done a trial for 20 kilometer, but it's in a static condition that user was sitting at one location and the site was there, and they were just static. But in the railways, we might not have that use case. We might, because we have a more of a mobility use case. So technically we can at any point 20 kilometer is doable, but from a railway application, I don't think so. It is a good condition to be.
Okay, Pavin. Pavin, that there is one participant who has raised his hand. Ajay Sharma, SSC Tele Kalyan.
Good afternoon, sir. Sir, I just wanted to know what will be the average downtime of a system, because as we are planning for installation in multiple stations, will it one station will one of the stations goes down? Will that affect my train communication?
Sorry,
Hello,
yeah, I
am I audible?
yes, sir, you are audible, but your question is not clear to me. That downtime means what? You are saying the once the network is live, then you are saying from that
Yeah,
perspective.
when my network is made live, and at the moment I found that my one of my station goes down.
Yeah,
Hello,
so sir, downtime means that
restoration time for one station. What
sir,
will
it,
be an average restoration time?
sir, it depends on the type of issue, technical problem which is being there at the site. Let's say, for example, the site is get burned. Let's say the whole system
Hmm.
catches fire. So maybe we need to
Okay.
replace the entire system. But if there is any technical glitch or some software issues, that could be addressed much faster.
But if in case that in that very moment the train is moving in that section, the train will again get connected when it comes into other network.
Yes, that will
Hello.
happen. As I
Okay.
mentioned, that the way that we plan the site is that there is a redundancy factor is always planned. Maybe you can see the slide the way we have done. So in case
Yes.
there is a one station gets affected, right? So
Okay.
even though this site is not available, the station 6 is not available, 4 is not available, 2 is not available, but other neighboring stations are able to give a coverage to this station.
If in case two neighboring stations goes down, then station 3 and station 4.
So then we have to think of some other solution, but that's very high probability that both the stations goes down at the same time.
Because there is a railway fiber network. Okay, if there is a maximum possibility when the two fiber between two stations get cut, and my station goes isolated. But when in that that very time my train is in the section, the TCAS and very other the very other application that we are talking about, will that work? And when it comes again in a network, I know that when there is in a dead zone, it will work. But when it again comes in the network, will it get back its all data that it has lost in back in a region?
No, so because there is no data storage as such happening, because TCAS is a live signaling, right? So
Okay.
as the train comes into the next stations where the coverage is available, it will start getting the recent feed which is coming there, because old data
Okay.
has no meaning here. It is not like a video, some movie we are
But
watching and then if we click on it.
We will be tracking train as well in the system, right?
Yes, that will be there. That will be there,
That
but
won't get lost. Because see, in Bombay division, we work in TMS. The TMS, when one station goes down, the train loses its ID. And when again it comes in the network, that ID gets lost. So will that be possible for train to restore its ID when it come again back in network?
sir, I am not an expert from that signaling, so I may not be able to comment you the right thing here.
No, I'm just asking about a train ID. If one train starts from station 1, it traveling to station 6. But in between 3 and 4, there are stations are my hop is down. So when train with the ID of Rajdhani Express enters the dead zone of 3 and 4, will again it will recover its in station 5 by its own. It's your application based thing, not
Yeah,
my
so
signaling one.
Ajay, Ajay,
Yes, sir.
Praveen won't be expert in that particular domain. I don't think that he'll
Okay.
be able to answer it.
Okay, sir. No, no problem. Actually, we faced this problem in TMS in Bombay division.
Okay, fine.
So that was the reason I was concerned about that. If it train ID gets lost, will it again recover when it network come back?
See, generally in LTE, suppose if you're moving out of the coverage area, and once you come
Yeah.
back to the coverage area, you will get automatically connected.
Sir, but my ID should not get lost because that will create a chaos in the section for
That
controller.
ID and all, it's something which is related to the TMS, right?
Yes, sir.
So it has got nothing to do with the LTE. LTE is only providing you a connectivity. And when it comes
Okay.
to TCAS, that we have to see the TCAS area. Okay.
Only TCAS. TCAS will get the TCAS will work because TCAS is the local application. The local network will provide it the information with the proper what your data we want.
Okay,
But it
fine.
was just train ID I was concerned about.
Okay.
Okay, so thank you.
Any other questions?
ये सर साइमल्टेनियसली अगर बोथ किसी स्टेशन के एडजेसेंट दोनों स्टेशन साइड्स में अगर मिड सेक्शन में कहीं फाइबर ब्रेक होती है फिर उसका क्या रहेगा सर?
Sir, fiber break is one part because you have a backup also, right? So you have a fiber, like somebody asked a question that can we have a connectivity from two paths? So yes, so
जैसे
you have a fiber across two tracks, two side of a track. We need to ensure that connectivity of transport is available from two paths here, so that even if one side of a fiber gets cut, second path is available to the central point.
Any more questions? Okay, then. Praveen, thanks for the presentation. Thanks to you and your entire Ericsson team. I hope the presentation was very much useful for all the participants, and you'll make use of it. Once again, I thank Praveen and the Ericsson team for giving this presentation and for their time. Thanks to all. And just one more thing. Actually, we have one more webinar that will be starting at 14:30. It's regarding planning and drive test tool, which are going to be used in LTE. Okay, so those who are interested may please join for this. Praveen, thanks a lot.
Thank you everyone.